Imagine a temperature so cold that the very concept of movement begins to disappear. Not Antarctica, not deep space, something far beyond both. And if Earth ever reached it, even for just 5 seconds, life as we know it would instantly unravel. Scientists call it absolute zero, the coldest temperature theoretically possible in the universe. A mind-bending minus 273.15 degrees Celsius. At this point, particles lose almost all motion. Heat vanishes. Energy disappears. Reality starts behaving in ways that seem impossible. But here's the strange part. Even the coldest place ever discovered in space doesn't actually reach absolute zero. The Boomerang Nebula, located thousands of light years away, is still warmer. That means absolute zero is colder than anything naturally known to exist. So what would happen if Earth suddenly dropped there? Right now, the air around you is filled with molecules racing through space at incredible speeds. You can't see them, but they're constantly moving. The warmth of your skin, the beating of your heart, even the thoughts forming inside your brain all depend on that motion. Then everything changes. In an instant, temperatures crash toward absolute zero. Air particles slow dramatically. Chemical reactions begin shutting down. The processes that keep every living thing alive start failing one by one. Your body depends on trillions of microscopic reactions every second. Breathing, thinking, moving, surviving. Without them, life cannot continue. And that raises a terrifying question. If the building blocks of life stop working, what happens to the planet itself? The answer is far stranger than you might think. Because absolute zero doesn't just freeze things. It transforms reality into something completely different. And that's when things get weird. As Earth plunges toward absolute zero, the danger becomes almost impossible to imagine. Most people think extreme cold simply freezes things. But this is something else entirely. At temperatures far warmer than absolute zero, exposure can already be deadly. Liquid nitrogen sits around 77 Kelvin. Touch it for only moments, and severe frostbite can destroy tissue. Limbs can be permanently damaged. Now imagine temperatures hundreds of times more extreme. Chemical reactions throughout your body begin slowing toward a halt. Signals struggle to travel through your nervous system. Muscles stop responding. Cells lose the ability to function. But that's not even the craziest part. As atoms become nearly motionless, quantum physics starts taking over. The normal rules of everyday life begin to break down. Scientists have observed a bizarre state of matter called a Bose-Einstein condensate. Under ultra-cold conditions, atoms stop behaving like individual particles. Instead, they merge into a collective quantum state. Think about that for a second. Millions of separate atoms suddenly acting like one giant atom. And this is where it gets weird. For a brief moment, parts of Earth could begin exhibiting properties that sound like science fiction. Matter could behave as a superfluid. Friction could disappear. Materials might flow in ways that seem impossible. Imagine entire regions of matter losing the resistance we take for granted every day. Suddenly, the planet isn't just freezing. It's transforming. Everything you know about solid, liquid, and gas starts blurring together under the influence of quantum mechanics. But there's a catch. Not every atom can join this strange quantum state. Only specific particles can behave this way, which means Earth would become a chaotic mixture of collapsing chemistry and bizarre quantum phenomena. And what happens next changes everything. Because despite all this destruction, the biggest surprise is still ahead. By now, it sounds like absolute zero would instantly erase Earth from existence. But hidden inside this nightmare scenario is a shocking twist. Absolute zero may be impossible to reach at all. That's right. The coldest temperature imaginable might never actually exist in reality. Here's why. If Earth somehow dropped to exactly 0 Kelvin, it would immediately begin absorbing heat from everything around it. Space itself contains energy. Radiation exists everywhere. The universe constantly exchanges heat. To keep an entire planet at absolute zero for even 5 seconds would require an infinite amount of energy and resources. Infinite. According to our current understanding of physics, that makes the scenario mathematically impossible. But here's the strange part. Being almost at absolute zero would still be catastrophic. Oceans, atmosphere, ecosystems, and every living organism would be pushed beyond recovery. Chemistry would collapse. Structures would fail. Matter itself would behave in unfamiliar ways. The Earth wouldn't simply freeze. It would become an unrecognizable quantum wasteland. A planet transformed into a bizarre soup of near-motionless atoms. And once those 5 seconds ended, there would be no magical reset button, no easy recovery, no return to normal. Everything would be different. Yet the most fascinating detail isn't the destruction. It's the fact that absolute zero sits at the edge of what physics allows. A boundary separating the universe we understand from one we can barely imagine. Scientists continue exploring this mysterious frontier, searching for clues about matter, energy, and the deepest laws of reality. Because if approaching absolute zero can produce effects this bizarre, what other secrets are hiding just beyond the limits of the possible? And what would happen if one day, somehow, we found a way to cross that line?